Good day. Today our group would like to present how to find the least square solution of the linear system. Given Ax equal to B, which is matrix A is equal to 2, 6, 9 in row 1 and row 2 is 7, 8, 6. Row 3 is equal to 4, 5, 3 and row 4 is equal to 3, 8, 7. And given B is equal to 7, 6, 8, 2. My name is Dilia Sharanta Anak Jalani and I would like to present how to find the orthogonal basis and orthonormal basis by using Gram-Schmidt to find the least square equation. So first, span A is equal to x1 equal to 2743 and x2 is equal to 6858, x3 is equal to 9637. So x1 is equal to vector 1, which is we find it from the span A, which is 2743. And to find the vector 2, we need to use this formula, which is x2 minus 2 open bracket x2 would multiply with v1 divided with vector 1 multiply with vector 1 close bracket vector 1. So we need to solve the equation in the bracket first. So x2 would multiply with v1, which is 6858 multiply with v1 is equal to 2743, and we get the answer is 112. Vector 1 multiply with vector 1 is equal to 2743, and we will get the answer is 78. So put the answer in the bracket. So we will get the answer is 112 divided 78 and multiply with the vector 1, and we get the answer of row 1 is equal to 2 at 71795. Row 2 is equal to 10.0512 to add 2. Row 3 is equal to 5743590 and row 4 is equal to 4.307692. And x1 minus with the answer, and we get the vector 2. 3, which is row 1 is equal to 3128205. Row 2 is equal to negative 2.051282 and negative 0.743590 for row 3, and row 4 is equal to 3.692308. By the answer that we get from the vector 2 and vector 1, we can find the vector 3 by using this formula. So just follow the step in V1, and then we get the answer for V3 is equal to, in row 1, 2.234760, and row 2 is equal to 0.526392, and row 3 is equal to negative 0.727931, and row 4 is equal to negative 1.747463. The vector 1, vector 2, and vector 3, we know that the orthogonal basis for column A is equal to 2743 for vector 1, vector 2 is equal to 3.128205, row 2 is equal to negative 2051282, row 3 is equal to negative 0.743590, and row 4 is equal to 3.692308 for vector 2. And for the vector 3, we know the answer is 2.234760, row 2 is equal to 0.526392, and row 3 is equal to negative 0.727931, and row 4 is equal to negative 1.747496. To find the orthogonal basis, we need to find the unit for the V1, V2, and V3, which is the unit vector for vector 1 is 78, and unit vector for V2 is 5.308436. Vector 3 equal to 2.975713. Divided the vector 1, vector 2, vector 3 with the each unit vector, and we get the answer of the orthonormal basis for code A, which is for the vector 1, we will get the answer 0.226455, 0.792594, and row 3 is equal to 0.452911, row 4 is equal to 0.339383, and for the vector 2, we get the answer in row 1, which is 0.589290, and row 2 is equal to negative 0.386413, and row 3 is equal to negative 0.140077, and row 4 is equal to 0.695555. And vector 3, we will get the answer 0.750999. Row 2 is 0.176896. Row 3 is equal to negative 0.244624. And the last row is equal to negative 0.587253.
Assalamualaikum Doktor. I am Aslina binti Hasim with matrix number D202010956668, and I will continue to explain about the QR factorization from previous presenter Delia. Alright, to find a value of x using a QR factorization and least square, we need to find first about the matrix Q and the R. So from previous question, we can define orthonormal basis has a matrix Q. After that, we need to make a matrix Q has a matrix Q transpose. Okay, so after that, we get the Q transpose, right? So next, after that, for the matrix R, we need to multiply by matrix Q transpose just now with a matrix A. Then we get the matrix R. So this is a matrix R has shown at the slide. So we get the matrix R. So after that, we need to find the inverse of matrix, because to find the value of x, we need to follow this formula where x is equal to R inverse multiply with Q transpose and B. Then we need to find the inverse of matrix. So we need to find we already find the matrix of R, so we need to find the inverse of R. So since matrix R is a square matrix, so we can find inverse using a formula where R inverse is equal to 1 over determinant of R multiplied with adjoint of matrix R. So at first we need to find the determinant of R. So after we perform the calculation, we get the determinant of matrix R is equal to 139.490786. So that's for the determinant R. So next, we need to find the adjoint of matrix R. So this is how we perform the to find the adjoint of matrix R. So don't forget to adjoint R at the end of this step. So we need to learn about the plus minus on the inside the matrix when perform the adjoint of matrix. Okay, so this is the adjoint of matrix R has shown on the slide. Okay. After we get the determinant of R and also the adjoint of matrix R, we need to substitute back the determinant of R and adjoint of matrix R into a formula for finding a inverse matrix. So we know that the determinant is 139.40978 so will be multiplied with the adjoint that we find just now as shown on the slide. So then we get this inverse of matrix R. So this is the inverse of matrix R lah. So after that, we need to find the Q transpose multiplied by matrix B. So we already find the matrix R that we will use on a formula. So we need to find the Q transpose multiplied with matrix B. We already find the Q transpose. So we need to multiply that to matrix B. So after we perform the calculation, we get the value of matrix of Q transpose is equal to 10.643403 and 2.077003, and the last one is 3.18608. So this for a Q transpose B. So after that, we already find the inverse of R, and we already know about the Q transpose and B. So we need to substitute all the matrix that we find when find and perform. So after do the calculation, we get the answer of X. Okay, after we do the calculation from the multiplication by inverse R and Q transpose and matrix B, we get the answer, which is the value of x1 is equal to 1.51977, x2 is equal to negative 1.10842, and the last one x3 is equal to 1.07098. So that's the answer. I think that's all from me. I will pass this video to next presenter to explain about the same method from Delia and me, but using a mathematical programming. Okay, so that's all from me. Thank you.
Assalamualaikum and hi, my name is Muhammad Amar bin Hasan Azahari. Now we are going to find the least square solution of this matrix. Okay, now by looking at this formula, you can see that we need to find the row reduction. The left hand side is A transpose times A and the right hand side is A transpose times B. Okay, so for the left hand side, first we need to find A transpose times A. Okay, so we already have the A matrix and matrix B. So first we need to find the transpose A times A. So we use this command. Now just running it by pressing Shift Enter. Okay, now we already have the left hand side. Now to find the right hand side, we also give the same command. Transpose A times B. Shift Enter. Okay, so this is the right hand side. So to find the row reduction, can use this command r equals to this is the value of x, so x equals to matrix form, because I want it to be formed in the form matrix. This form to reduce, so reduce of this matrix. So 3, 4. These are the matrix need to be put in this row reduce. Okay, then press Shift Enter. Okay, but here we it is shown in percent fraction. So to make it form in form of decimal, we can use command N. Right. So Shift Enter. Okay. So these three are the least square solution of this matrix. Okay. That's all for now. Thank you. Okay, hi, welcome back. Now we are going to find the value of x from the same matrix of the same linear systems, but now we are going to use QR factorization. Okay, so, for QR factorization, it is so simple. We just need to put the value of right hand side of the system, the value of b, and then to the QR factorization, we just need to put this command. Okay. Q and R, QR decomposition of the matrix A. This is the left hand side of the system. Then just press Shift Enter to run it. Okay. Then what I need to do is we're gonna count the value Q. I want it to be in matrix form. Shift Enter. So this is the value of Q. Then I call for the value of R. I also want it to be in the form of matrix. This type matrix form. Press Shift Enter. So this is the value of R. So to find the value of x, I just put x equals to inverse R times Q times B. Okay, I put this command here because from the formula, R times X equals to Q times B. So to find the value of X, it is the inverse of R times Q times B. So this is the idea, what I put inverse here. So by pressing Shift Enter, this is the value of X actually. but it's too long. So just to make it short, I put some comment here and shift enter. Okay, so this is the value of x in decimal form. So I want it to be also in the form of matrix. So I write matrix form. Okay, so this is the value of x, but now we are using QR factorization. Okay, so that's all from me. Thank you.
Okay, to find the orthogonal bases, we will have to perform Gram-Schmidt on eigenspaces, which U1 is the projection of 2743, which is the same as the column 1 in matrix A. Okay. While U2 is 6 at 5 at, which is the second column of matrix A, minus with projection 6 at 5 at U1. So we will get 3.12 at 1 minus 2.05128 negative 0.743590 3.69231. And we're going to find U3, which is 9637, the third column from matrix A, minus with projection 9637 U1 minus projection 9637 U2, and we will get the U3 equal as 2.23476 0.52638 at minus negative 0.727934 negative 1.749 at 1.74750. So then we will get the matrix like this. Okay, so then we will gonna find the orthonormal bases, which is Q1, Q2, and Q3 in 6 decimal places also. So to find this, we will have to normalize U1, U2, and U3, which we'll get from the orthogonal bases. So Q1 is equals to square root of 2 over 39 as stated, to 7 over square root 78, to square root 2 over 39, square root 3 over 26. While Q2 is 0.5892 at 9, negative 0.3 at 6419, negative 0.140077, 0.6955555. Okay. Then to find Q3, we're gonna normalize U3. Then we have 0.750999, 0.176 at 95, negative 0.244625, negative 0.587253. So this is how we got the orthogonal and orthonormal basis for the matrix A.